Moldex 3D has partnered with Sodick and CoreTech to run a full mold analysis using a stylized bubbler system and a hot runner manifold. This 8-cavity setup evaluates the impact of cooling design and hot runner layout on part quality. Moldex 3D's machine mode allows for selection of a Sodick V-line Two-stage Plunger, and the machine interface allows for input of the machine parameters directly into the simulation. This makes the correlation from simulation to reality a breeze and is an important role in developing a digital twin for smart manufacturing. The balance of flow through the part geometry is important, but for a multi-cavity system like this one, the similarity from cavity to cavity is even more important to ensure every part coming out of the mold is up to quality standards and to decrease plastic waste. To visualize the root cause of potential cavity-to-cavity imbalance, Moldex 3D's true 3D solid mesh can capture any thermal imbalance in the runner created by the flow of plastic. This can be done for both hot manifold systems as well as complex cold deck layouts. The pressure loss through the system dictates how large of a machine is needed, so therefore having an accurate depiction of pressure drop through the cavities and runner system is imperative to anticipating the cost of production. Moldex 3D can model complex geometries and can separate the pressures in the parts and runner geometry. The thermal distribution doesn't stop at the melt system, though. Moldex 3D uses 3D solid mesh for all components of the mold, including the mold geometry itself, enabling a cycle-wise thermal profile animation to see how the mold temperature is cycling over the duration of the molding time. Cycle time estimation and the cost evaluation of a complex cooling system can easily be run in Moldex 3D's true 3D analysis.